can see the screen now?
Yes, sir, it is visible.
Yes, sir.
Unless you read the books properly and thoroughly, line by line, you will miss many points, because one line will have such a deep meaning which immediately you may not realize, but the effect of that you will see maybe toward the later part of the book. So since I've read the book a number of times, I know when I'm reading which line is important. So sometimes I tell the students, this line is important, pay attention, underline it or mark it, so that some children do, some don't do. So I actually don't have control over what you people are paying attention or. But the point is, everything is mentioned in the book. You see over here, the varying speed of the Earth in its orbit causes the seasons to be of unequal lengths. The autumn, spring, summer, and winter, they are slightly of different lengths: 93, 94, 90, and 89 days. Does this answer your question?
Yes, sir.
Yeah. ये क्लास में भी मैंने बोला था, वो स्पीड में अलग चलते हैं, वैसे कोई डिस्टेंस कम है, कोई ज़्यादा है. I'll give you another example how astronomers used to understand something. जैसे ये पिक्चर है, let's say this picture. If from the maximum western eastern elongation V5 to maximum western elongation V2, this arc of the circle looks shorter than V2, V3, V4, V5. Am I right?
Yes, sir.
So when people are observing a planet, a star, for so many years, maybe centuries, then slowly they start realizing what is the path, what is the scenario going on behind in the sky. So these things are very important. Nowadays, of course, we have computers to simulate the situations and things are much faster. But earlier, the observations, people used to get confused why this is happening, why that is not happening. Like when we study the chapter time, next week first I will do celestial sphere, then I will do time. Time is another very important and complicated chapter if you want to understand. How do we measure time? What is known? Why the sun is not overhead at exactly the same time? Why there was a slight difference? People made the sundial, but still the shadow was having slight difference. So these sort of things, very interesting things are there. So the point which I'm trying to make is, you should pay attention to every word which I say and every line which is in the book. And once you understand the celestial sphere and navigation, this one, no, it is very easy to solve the numericals and problems. Otherwise, you will be breaking your head and you will not get the picture, how to imagine, what to imagine. Like the other day, yesterday when I did that, it took me just a few seconds to find the elongation of Mercury. Similarly, there are so many numericals in the previous chapters which are a part of your TCNO. Are you doing those numericals? Have you been asked to do those numericals or no? Chapter 1, 2, 3, 4, like that. Yes or no? Someone should give an answer, yes or no, whatever.
No, sir.
But these chapters have been covered. Let me take you to the first chapter here. Is this the first one? Yeah. So, okay. We'll spend a few minutes on this. I will just show you the importance of. Just go to the exercises of each. These are very simple D-lat, D-long types. Compass error, parallel and plane sailing. Once again, simple formulas: D long, departure by D long is equal to cross lat. This is a very simple formula, but the numerical can become complicated. I will give you an example. Two vessels on the equator, 60 miles apart, both steered 180 until they reached latitude 30 south. Find the distance between them on latitude 30 south. The D long is the same, but you just have to calculate the departure. Read the fourth one. Two aircrafts, latitude 60 north, 90 west, depart at the same time, one flying east, other west at 500 knots. In what longitude will they meet if there is a 30 knot easterly wind? Try doing this, very interesting. Have you done this exercise or no? Any question you have done over here?
No, sir.
So if this particular
No,
one
sir.
question, if you are able to do this one question, this entire chapter and a lot of things will be clear in your mind. So just try doing this. Let me know during the weekend if you can do it. Monday, if you want, you can discuss with me. Somebody else has taught this, so I will not go into it. But the point which I am trying to make is these exercises are good, harder problems. That is a simple one. These are harder problems. Ship in such and such position steers 090 at 10 knots for 20 hours. She then alters 90 to starboard, covers certain distance. Thereafter, the course is altered further 90 to starboard. She sails on this course for 22 hours and arrives in 20 east. Again, find the distance covered. Once you make this diagram, and you can imagine, should not be very difficult. Formulas are the simple ones. Departure by D long is equal to cos lat. The exercises after the chapter will include only that formula. Sometimes you get these questions in your exams also. So try it. Some of them are solved. So do the solved ones first, and then maybe you can get a hang of it. There's another interesting one over here. See the diagrams, how the ships are moving and how you have to calculate. Two ships start from the same point in the northern hemisphere. First ship steered 30 true 10 knots, second steered 0 at 12 knots for 2 hours. And then altered course 90 degrees true. Calculate the distance between the two ships 6 hours after starting. So both ships are going in different directions. You have to calculate the distance between them. So actually, if you do all these things, then it becomes easier in the celestial navigation also. These probably you may not be doing now. Of course, Mercator you will be doing D long by DMP, but constructing the Mercator chart probably in phase 1. These are again very critical types. This in phase 1 maybe you'll have to do. So I won't tell you to do this one. Forget this one. Calculations of the natural scale. This is of course Mercator sailing. This you will be doing in any case. Have you reached this chapter or no? Have you reached this chapter in TCNO, Mercator sailing? You must have done because you have done day's work. Yeah?
Yes, sir, done.
Okay, good. So during the weekends, try to cover up, be in touch with your exercises and chapters, then you won't have to work very hard towards the end. So next week I'll be doing this celestial sphere, this chapter. During the weekend, read this one. Maybe I'll take 1 or 2 days to cover this, and then we'll go on to time. This chapter will have some exercises also. Important relationships, GHA, LHA. Yeah, these are very simple exercises. If you have understood the diagrams very clearly, there are 2 or 3 types of diagrams only. Nothing much to worry. These types of simple questions, which you can do in half a minute maybe, come in the exams, and you can get very good marks if you know how to draw this. So we'll be doing all these exercises, don't worry. Solar system, we finished. So we were doing Earth Moon system. I told you I'll be doing eclipses today. What I'll do, I'll just quickly run through this one once again. There's another slide that I have, maybe 5 minutes. So the moon revolves around the Earth, and as a combination they revolve around the sun. The Earth rotates once in 24 hours on its axis. The moon also rotates on its axis. But how long does the moon take to rotate on its axis? Anyone? We know the revolution takes either the sidereal period of 27 days or 29 days, synodic period. That is the revolution. But how long does the moon take to rotate on its axis? Anyone? Yesterday we spoke about it. Somebody said he wants to read the chapter before we go further. Who was that gentleman? Did you read? Did you get the answer to my question? Very silent class. I don't know why today.
So 27 days.
It takes exactly the same time for the moon to rotate as it takes to revolve around the Earth. That is why we see the same side of the moon every day. It does not change. It looks as if it is not rotating. It looks as if it is not rotating because the same side is being presented to us all the time. But actually it is rotating at the same speed as the revolution. So we feel we always see the same side. Okay, so here again the orbit is elliptical with Earth at one of the foci. The distance keeps changing because of the elliptical path. The closest, what we call perigee, is 221,000 miles and apogee 250. So we take the mean distance as 240,000 miles. For the sun, we said aphelion and perihelion because helion is the sun. Here we say G, perigee and apogee because Earth, it is moon and the Earth distance. So if you are measuring the distance from the moon, then there is another word, we'll come to that. Sidereal period of the moon is the time taken to complete one revolution around the Earth of 360 degrees. Remember in the diagram that I made yesterday, I'm not talking full moon to full moon or new moon to new moon. 360 degree revolution will take the sidereal period, 27 days, 7 hours, 43 minutes and 12 seconds. That is the Earth moving from the top position to the lower position. And the horizontal line pointing to the star at an infinite distance. But if you want new moon to new moon, it will take another 2.2 days because they have to be in conjunction once again. The Earth, Moon and the Sun are in one line on the top, but bottom they are not in one line. Only after 2.2 days, then you can see the Moon has moved a little further. Then the Earth, Moon and the Sun are in the same line. So you will see the new moon after 29.5 days. So that is the synodic month. These are similar diagrams. Different methods of showing the similar diagram. So synodic period is 360 degrees plus the angular motion of the Earth around the Sun during the period. Again, same things. Synodic period of the Moon. So we come to another term over here, perihelion and aphelion. Yeah, this is for the at perihelion, angular motion of the Earth around the Sun is larger. At aphelion, the synodic period. This one you can skip. Yeah, Moon's rotational motion is synchronous with its orbital motion. That is, the Moon rotates on its axis, completing one rotation in its sidereal period. For this reason, Moon presents same side to Earth, and hence we see same features of the Moon. I don't know how many of you have started the exercise, but I hope you look at the Moon every day and see how she changes the shape. The plane of orbit of Moon is inclined to the plane of ecliptic by 5.14 degrees. This we saw in the diagram where I was trying to show you the nodes. So ascending node, descending node we discussed. The nodal points are not fixed, rather they move westwards at 19 degrees per year, completing one cycle in 18.6 years. So the maximum declination of the Moon that you will find is 23.5 plus that 5.16 or whatever. We spoke all this yesterday. I will not repeat this one. Phases of the Moon. We see different shapes of the Moon at different times of the month. This is another good diagram of the phases. The Earth is in the center. The picture on the right is the new moon, sun rays falling on the moon, but you cannot see. You can see the darker side of the moon. So the upper quarter diagrams are waxing when the size of the moon is increasing. Remember the side of the moon which is facing the sun remains illuminated. That is why the crescent from new moon to full moon, the crescent is in a different direction. When it rises, the convex side is towards the horizon, and from full moon to the new moon, the convex side is on the other side. Figure number 4 is full moon, when you can see the light of the sun falling on the moon. Then there is another situation called gibbous half moon, and then the crescent. The video was also quite clear yesterday. Another picture over here. Another one. Now in this revolution of the moon around the earth, there is one more phenomena which takes place. By looking at the phases of the moon, you will think that maximum what you can see is 50% of the moon's surface, that is at full moon. Am I right? Because the other 50% is on the other side. Earlier we said that the same side of the moon is presented to us all the time. So at new moon we see nothing. Then it starts increasing. The area at full moon should be 50%. Do you agree with me that 50% is the maximum area of the moon that we can see? Yes?
Yes, sir.
Yes, sir.
Anyone has a different answer? Anyone has a different answer? Do we see 50% of the moon's surface, or we see a little more? We'll come to that in a few moments. We also discussed yesterday about the daily retardation of the moon. Every day the moon rises 50 minutes later, because the moon is also revolving around the sun, so it has moved a little further. And again, the earth has to rotate a little more to come in line with the moon. So 12.2 degrees, which yesterday you calculated, it takes about 48, 49 minutes. So this is how it is. If one day at new moon, the earth, the moon and the sun are in one line, the next day the moon has moved a little further, 12.2 degrees, because she has to complete the revolution in 29.5 days. So in one day she will move 12.2 degrees. So in order for the same situation to happen, let us say the moon and the sun rose together one day. So the next day the moon will rise 50 minutes later, because the earth has to turn a little more to bring the moon at the same position. This point is clear to everyone? So about 49 to 50 minutes. This is important because when we will be doing the practical calculations on the moon, then you will have to do this correction also, longitude correction, and in the tables and in the almanac we have to refer to this. So just remember this point always, that the moon rises 50 minutes later every day. Average length of the lunar day is 24 hours 15 minutes. So this is another important phenomena of the moon, liberation of the moon. Liberation of the moon. Here you must imagine a little bit, visualize, apply your mind on what I'm going to say next. Now you will see 50% of the moon only if the path is circular, if it is not tilted in its axis, it is absolutely vertical, and if everything else is going as per standard normal practice. But we know this is not the case. The moon is revolving, the moon is rotating, the path is elliptical, and the most important thing is the moon's axis is also inclined. How much was the Earth's axis inclined for rotation? How many degrees was that?
23.5 degrees.
23.5 degrees. So moon's axis is also slightly inclined. We will see how much. it would appear that an observer on Earth would see only 50% of the moon, and the other 50% back portion will not be visible. But this is not true. Due to rocking and wobbling of moon called libration, we see an additional 9% of the moon's surface area, though at any given time only 50% may be visible. At any point of time on the full moon you will see 50%, but which 50%, that is different. So you will see 50 all right, but out of the 59% you will see any 50%, but 41% is not visible at all. Moon's axis is inclined 6.5 degrees from the vertical to its orbit. So just like we discussed the seasons, that the axis of the Earth is pointing to a fixed direction in space during the winter and the summer solstice, the northern hemisphere either was facing more to the sun or southern hemisphere. Am I right? You remember that one? The sun was shining either on the Tropic of Cancer or on Tropic of Capricorn. Either the Arctic Circle was having full day and Antarctic Circle was having full night. You remember that point? So similarly over here also, since the moon is also inclined and it is going around the Earth, sometimes the northern part of the moon is more visible, sometimes the southern part is more visible. I'll just show you a diagram so it will be a little more clear to you, which is a good diagram. Is there a better diagram in the book? Let me see. I don't think the book has a diagram on this one. No, the book does not have a diagram. Let's try to make do with this only. The Earth is in the center, and you can see the axis of the moon, P dash 6.5 degree. So to an observer from the Earth, if you look at the left moon, you can see more of the North Pole. Am I right? And if you look at the moon on the right, you can see more of the South Pole. So you can see up to that dotted line on the top, and bottom also you can see up to the dotted line beyond the South Pole, beyond P dash. So this little bit of surface area which you can see extra is called liberation of latitude. That means in the latitude you are seeing a little beyond the North Pole of the moon and little beyond the South Pole of the moon. Is this point clear to you? You are seeing a little more above on the latitudes. Similarly, there is liberation in longitude also. This happens due to the wobbling of the moon. Now, what is this wobbling? It actually does not wobble, but due to the elliptical path, it will look as if it is wobbling. How? Let us see. Its orbital motion is not uniform. Orbital motion is smallest at the apogee and largest at the perigee. Once again, because of the distance from the Earth and due to the angular velocity being more or less, being more or being less. Now here somebody asked that question about Kepler's second law. Just try to relate with this one. If a body is moving a little faster, but the rotation speed remains the same, You will see more or you will see less? If the body is moving faster in the orbital motion as a revolution, but the speed of rotation remains the same, you will see more or you will see less? Try to think and imagine. Body is rotating at the same speed, but the movement becomes faster. So at apogee, she is moving slow. At perigee, she is moving fast. So think that you will, from the vertical point, from the longitudinal point, you will see a little more on either side. Because of the tilt in the axis, we saw a little more on the latitude side. But because of this elliptical path and an apparent faster motion, orbital motion at apogee and perigee, we see a little more on the longitudinal path. Maybe this diagram may give you a little more better clarity. On the left side is apogee, far. So it will look as if it is moving a bit slow. But on the right side is perigee. It will appear it is moving fast. But the rotation of the moon remains the same. Gentlemen, you have to use your imagination over here. It might be difficult for me to explain on the board also, but this diagram is quite clear as far as the explanation is concerned. You have to imagine the rotation is the same speed, but movement along the revolution path is faster and slower. So the vertical side of the moon, the longitudinal side, either you will see a little more or a little less. In the sense, you might see, once you might see the eastern part a little more, once you might see the western part a little more. So let us see this one, this slide. At apogee, moon's rotational velocity is greater than its orbital velocity. Orbital velocity greater than the rotational velocity required to present the same side of the moon towards the earth. In consequence of above, moon appears to turn around slowly, and we are able to see more of the eastern side of the moon's surface. I will see if I can find a video on this, but this topic is more out of academic interest than any practical value. So, but since you get a question on this sometimes, you know, in your exams, so I'm trying to explain to you. So the moon appears to turn slowly when at apogee because it is far away. So you see more of the eastern side, but at perigee, the rotational velocity becomes less than the orbital velocity comparatively. In consequence, we see a little more on the western side of the moon. So the total extra of the moon that we can see, north, latitude, south, east and west, is about 9% of the surface more than the actual, but at any given point of time, we will see only 50% because we cannot see beyond the curve in any case. There is another liberation called diurnal liberation. That is when the moon is rising and when the moon is setting. When the moon is rising, we are able to see a little more over its top or the western edge, and likewise a little more over the eastern edge while setting. Is it something like this? Can anyone tell me why this is happening? This may be If you
Refraction,
can
sir?
understand this, if you can understand this, you can understand the others also. Tell me.
Refraction, sir?
Refraction. A good attempt, I would say, you're thinking, but in this case, no. Anybody else? Why it says that you are able to see a little more? While rising and setting.
Sir, tilt of moon axis.
No, not tilt. The answer is very simple, but you do it every day at sea also. It's a very simple, but sometimes, you know, we start thinking in the difficult direction, so we miss out the simple things in life. Have you heard of height of eye? Yes or no?
Yes, sir.
Yes, sir.
So higher the ship, you can see more of the horizon. Lower the height at sea level, you see less of the horizon. Am I right?
Yes, sir.
So here
Yes,
imagine
sir.
this is the height of the earth. One fellow standing on the top, one fellow standing at the bottom. What would be an observer who's standing here? You can see my cursor moving. You can see my cursor on the screen.
Yes,
Yes, sir.
So a person who's standing on the earth over here, he's also standing on the earth. This fellow is also standing on the earth, and this fellow is also standing on the earth. But there is a difference between this person, how much he can see of the moon, and a person. Where's the cursor gone? Yeah, and the person who's standing here. Can you imagine this point which I'm trying to say? This is a very interesting point. This will help you in the augmentation of the moon also to understand. Augmentation of the moon semi-diameter. Okay, let me tell you the answer. The person who's standing here, he is in direct line with the moon. Okay. That means the moon is on this meridian over his head. But a person who's standing here, he is seeing the moon rising. The earth will rotate west to it. He is seeing the moon rising. So when he's seeing the moon rising, you can say the moon is down and he is up. So he can see a little more beyond what this fellow can see. This fellow can see only as far as this point, but this fellow being on top, he can see a little more. Another way of looking at it, though it is not related directly to this. This person and the person over here both are standing on the earth. Who is closer to the moon? Nearer to the moon? The person standing on top or the person standing here where my cursor is? Who is closer to the moon?
so the cursor one.
Pardon?
So where was your cursor? That
Cursor. Why? Why? Your answer is correct, but why? Anybody? You see, distances are measured from the center of the bodies, center of the earth to center of the moon. Okay. These two people are in line with the center of the earth. So the diameter of the earth is 8,000 miles. So 4,000 miles is the radius of the earth. So the person who is here, he is 4,000 miles closer to the moon. It is 4,000 miles. Now 4,000 miles over a mean distance of 240,000 miles carries some meaning. So he is closer and the moon looks a little bigger to him. It looks bigger, but it is not big. So that of course will come to later. Just because I was at this topic and this picture gave me an idea, so I spoke to you about that one. But the liberation is clear to you or no? The point which I'm trying to make, the person standing over here, he is at a higher height, and so he can see a little more beyond what the person standing here can see. Is it clear? Shall I move on? Gentlemen, I need you to say yes, no. Otherwise, how will I know? Are you there in the class or no? Shall I ask you to switch on your cameras?
Yes, sir.
Yes, sir.
Why are you not interacting? At any moment, I may ask you to switch on your cameras. We have somebody watching. There is a class monitor. You are aware of that. So we can always observe how many people are there or not there. So make sure you're there in class all the time.
Yes, sir.
Okay. So let's now go on to the topic of the day, eclipses. I hope the revision was a refresher for you. And we'll go on to eclipses. I will use the board now. After using the board for some time, I might show you a video also. We'll start with the solar eclipse. All of you have seen an eclipse, either solar or lunar?
Yes, sir.
Anyone who has not seen an eclipse?
Yes, sir.
So which one have you seen? Both?
Solar, sir.
Solar. They say it is easier to see a lunar eclipse than a solar.
A lunar eclipse or day before yesterday.
Yes, lunar eclipse happened day before yesterday also. So what was day before yesterday? It was full moon.
Yes, sir.
That is very important point. The lunar eclipse happens only on a full moon. Did you get a chance to see it or no?
No, sir.
Why?
So because it was just rising, sir. We couldn't able to see in India.
Yeah, it happened in the southern hemisphere. People in Australia and some other parts, western hemisphere, they saw. So that is why we could not see. So are you able to see the board?
Yes, sir.
Let me position it slightly like this. I think now it's the full board you can see. Okay. So we have the sun over here. ज़्यादा बड़ा मिल गया. We have the sun over here, and we have the earth over here. And we'll place the moon here. So the rays of the sun will come to the earth, but there is a moon in between. So the shadow of the moon will fall on the earth. Actually, the board is a little away from my hand, so it's not coming clearly. Anyway, something like this you can say. Learn to draw these diagrams because eclipses are very common. Everyone saw this? You can see this clearly now?
Yes, sir.
So when the moon comes between the earth and the sun, then the moon will obstruct the rays of the sun in this manner. So this part of the earth is not getting the sun properly. This part of the earth is not getting the sun properly. But there is a slight difference here. This part is more darker. This part, that means this portion. This portion cannot see the sun at all. It is totally dark. Let me make it more dark. But this other portion can see part of the sun, and part of the sun is blocked. You can see if you draw the direction like this. If you draw the direction like this.
बोर्ड नहीं दिख रहा है सर, ब्लर हो गया.
Blurred.
Yes sir, बीच में वॉइस भी लैग कर रही है सर.
We couldn't able to hear you.
क्लियर दिख रहा है सर, क्लियर दिख रहा है.
Yes sir, now you okay.
No, sir. Clear, sir.
Okay, maybe some wavering of the signal. So the people who are in this part of the earth, for them the sun is totally blocked. But for people in this part and this part of the earth, they can see half of the sun. Half of it is blocked. So if you look at this direction like this, you can see that half of the sun will remain blocked. And if you see like this. Now solar eclipse is of three types. Full, partial, and annular. What is the difference between a full, partial, and an annular? And what are the conditions that will? What are the suitable conditions for the eclipse to take place? Now in this diagram, what do you see? That the earth, moon, and the sun, they are all in one line. When I say that they are in one line, for any heavenly body, we always mean the center of the three heavenly bodies. So the center of the sun, center of the moon, and the center of the earth are in one line. They are in conjunction That means from Earth, if I take a bearing of the moon and the sun, it will remain the same. So the Greenwich hour angle from the Greenwich meridian or sidereal hour angle from the first point of Iris will be the same. Earlier we said that eclipses happen during the nodes. Whenever there are the nodes, at that point the eclipse will happen. So what hint does that give you? Anyone can tell me what other condition needs to be fulfilled? If the eclipses will happen only during the nodes, ascending node and descending node, what other important condition needs to be fulfilled? First condition is they should be in conjunction. Second condition, GHA, SHA, same. Third condition. Okay, let me give you another hint. In this situation, is it a new moon or a full moon?
Sir, new moon.
New moon, very good. Because this part of the moon is dark, the one that is facing the earth, and this part of the moon is getting the sun, which is bright. So it is new moon. So very good. New moon. So for a solar eclipse to take place, it can happen only on a new moon. But we don't have solar eclipse 12 times a year, because 12 times a year we have, or 13 times a year we have new moon. Am I right? But do we have 13 eclipses? I don't think so. So I've given you two hints. You should be able to give me the other important condition.
Sir, declination of the both should be 0.
Yes, very good. Half answer correct. Declination should be same. Declination should be same, or very nearly the same, and it should be the same name. Either it is north or it is south. Because if there is a big gap between the declination of the sun, the ecliptic, and the moon, then the eclipse will not take place. There will be a gap, no? So, and you know the nodes are also shifting. If the nodes are shifting, the sun's declination remains the same, no problem. At 0 declination also there can be eclipse. At 10 degree north, 10 degrees south also there can be eclipse. At 20 degrees south also there can be eclipse, because the nodes are also shifting. You get the idea? Yesterday we spoke about the nodes, no? So the path of the ecliptic and the path of the moon, they were different, but where they were intersecting, this node is also shifting along the ecliptic. So whatever the declination, if they are nearly the same, the node may be at any point. It takes how many years? 18, 19 years, we said. So wherever the node is, doesn't matter, but eclipses take place near the nodes because the declination remains the same. Same declination and the same name. Same declination, same name. If it is north, north, south, south. Both have to be either north, north or south, south. Declination of the sun and the moon. So, is this clear, gentlemen, so far? We'll take a break, we'll come back and we'll discuss what is full, what is partial, what is annular. Is it okay?
Okay, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Thank you. You can go and have your break.